It hadn't been my first year teaching the course, and we hadn't gone virtual. So, generally we try to shoot for 100. But
Are you a math teacher or what?
both. All right, lesson 9, page 43. So earlier this week we had talked about a bit about adding and subtracting signed numbers. When we talk about signed numbers, what do we mean when we talk about signed numbers? Not with exponents. Not dealing with exponents yet this year.
Inverse and positive.
Negative or positive, right. Numbers that have a sign in front of them, either negative or positive. If there's no sign, then we assume that it's what? Positive. Okay. So last week we talked about, earlier this week we talked about adding and subtracting signed numbers. Now we're going to talk about multiplying and dividing. Signed numbers. All right. And this is actually, I think, easier than adding and subtracting. What's our rule for when we multiply or divide signed numbers? Not always.
No, not always. Negative times positive is positive.
So, it wasn't mine, no. All right, so if we've got two positive numbers, our answer is going to be what? Positive, negative?
Positive.
Positive, right. 2 times 5 is 10. Positive 2 times positive 5 is positive 10. Okay. Here, I can even write that example. 2 times 5 is 10. All right. One positive and one negative number. What's it going to be? What if instead of 2 times 5, we have negative 2 times 5?
It's going to be positive. Negative.
It's going to be a negative. Negative 10. What if we've got 2 negative numbers?
It's going to be a positive.
It's also going to be positive. Negative 2 times negative 5 gives us positive 10. And that's the thing to keep in mind. So just like when we had our negative signs, remember the negative sign, one way we can think of it is times negative 1. So if we've got 2 negatives, they'll cancel out and we'll end up with a positive. The general way we can state this rule is that if there are an odd number of negative numbers, so if there's 1 negative number, or 3, or 5, or 7, or 9, then is our final answer going to be negative or positive?
Positive.
If there's 1 negative number, or if there's 3 negative numbers, our final answer will be negative. Right? Negative 2 times 5 is 1 negative. 1's an odd number. If there are an even number of negative numbers, including 0, because remember 0 counts as an even number, then our answer will be positive. Because 2 negatives will always cancel out. Negative times a negative gives us a positive. Just like we saw negative 5 is positive 5. Because that means negative 1 times 5. Otherwise, so that's how we tell our sign. And then where do we get the number after the sign? So negative 2 times, so 2 times 5 is 10, right?
Mm-hmm.
What about negative 2 times 5? So we knew that since it's 1 negative number, it's going to be negative, our answer. But where did we get the 10 from?
5.
It's still 2 times 5. We're going to multiply the numbers like normal, as if they didn't have signs, so 2 times 5. And since there's 1 negative number, we know it needs to be negative 10. Here again, negative 2 times negative 5, we multiply 2 times 5 and get 10. And since there are 2 negatives here, we know our final answer has to be positive. So we leave it as positive 10. If we are dividing, it's going to be the same deal. So if we have 6 divided by 3 is what?
2.
Is 2. What about negative 6 divided by 3?
-2.
Negative 2. What about 6 divided by negative 3?
-2.
Also negative 2. What about negative 6 divided by negative 3? Positive 2. The same rule applies. We divide like normal, and we can tell which sign it's going to be by counting the number of negatives. As we've been saying, the reason why this applies to both multiplication and division is because multiplication and division are considered, are what we call inverse operations. It's the same thing in different directions. The reason why 6 divided by 3 is equal to 2 is because 2 times 3 gives us 6. The reason why negative 6 divided by 3 is negative 2 is because negative 2 times 3 gives us negative 6, etc. And the reason why negative 6 divided by 3 is 2 is because 2 times negative 3 gives us negative 6. You can undo division with multiplication. So for example, if we have something like this, what if we have this fraction? Or maybe better if I write it this way, 7 times 2 on top. What is this equal to?
-7.
7. How do we know it's equal to 7?
7 times 2 is 14 divided by 2.
Okay, we can calculate it out. We can also notice that we're taking 7, and then what are we doing to it? First we're multiplying it by 2, and then what are we doing?
Divided by 2.
Dividing by 2. So multiplying by 2, we're going to undo that by dividing by 2. Whatever the second number is, as long as it's the same, it could be pi. Okay, we're not going to bother doing that calculation in our heads. 7 pi divided by pi is still 7. Because up top, we're multiplying 7 times pi, and then we're dividing by pi. Multiplying by pi and dividing by pi are undoing each other. They're going to cancel out. The same way that adding a number and adding its negative, or adding a number and subtracting the same number will undo that. This is how we undo multiplication. We can undo division this way also. It doesn't matter. We could say 7 divided by pi times pi. 7 divided by pi, that is definitely not something that I'm going to want to calculate out. First of all, it involves pi. Second of all, it involves division with a decimal. I hate both of those. Why? The difference with the decimal, you have to like move the decimal points, and then usually you're multiplying like, it's also going to be basically impossible. So, right, if we do 7 divided by 3.14, okay, first thing I got to do this. So then I got to move this decimal point. So I've got 700 divided by 314, and then it's going to be 314 times 2 is 628, okay, and then I'm going to have, I'm going to have 72 left over. Then I'm going to have to carry down another 0, 720, and like I'm just going to, no. We can skip all that by recognizing that this dividing by pi is followed by multiplying by pi. They're undoing each other. Two last things. These rules about division apply to fractions also, because remember the fraction sign means divide. So we said 6 divided by 3 was our example there. So we can write as 6 over 3 is 2. Negative 6 over 3 is negative 2. 6 over negative 3 is negative 2. Negative 6 over negative 3 is positive 2. And here, we can think of it as canceling out. In this one, there are no negatives, so it's going to stay positive. In this one, there is a negative, which makes it negative. In this one, it doesn't matter whether the negative is on the top or the bottom of the fraction. As long as there's one, the whole thing is going to be negative. With this last one, we've got a negative on the top and a negative on the bottom. We can think of those as canceling each other out, giving us positive 2. If the signs are the same, we're going to get a positive, and if they're different, we'll get a negative. That's a simple way of expressing these. So if they're the same, either 2 positives or 2 negatives, then we'll get a positive number. And if they're different, then we'll get a negative, about less than 9. I'm sorry?
My concern is.
Well, there's 24 minutes left in the period, so I think you guys will be able to finish it during this time. If there's anything left, it won't be very much. So let me tell you which problems it'll be. And actually, I guess I'll pass out the sheets first.
Yeah.
And then the first one's going to be number 4. What was that?
We're able to do the test, right? You said we're able to fix problems.
Yes, yeah. If you want to work on test corrections now, you can do that also.
So are we able to do that over the weekend?
Yep. Yeah, test corrections will be due on Tuesday because we're not going to go over the test on Monday. So test corrections will be due on Tuesday. Yep.
You said you can't do it.
If you only lost 1 point on a problem, you can't do corrections. That's right. Okay, so 2 things. Test corrections due. Test corrections due on Tuesday. Did we do 8?
Yeah. I don't think so. Yeah, we did.
No, we didn't. How did we skip 8?
Because we're so good at this, we don't even.
I guess so. All right. Well, anyway, I guess we skipped 8.
Wait, no, did you say the lucky chapter 8?
No, I don't think
We
so.
don't need that. It's so good.
We don't even know that. We learned it last year.
Yeah.
Well, all right. So anyway, yeah, take a look at 8 when you get a chance. I'll spend some time going over 8 maybe on Monday after we review the test. We'll have some time there. All right. So problem set 9. Here's the set of problems you need to do. So 4, 5.
How did it do?
Dot, 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 12, 16,
Wait, 5 through 12?
17, yep.
Oh, yeah, I know.
Okay, 17, 18, dot, 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 27. And test corrections by Tuesday. Those are optional. We are also going to go over a number of these problems on Monday. So if you want to ask about them in Monday's class, if you want to wait till then that's fine.
So on number 4, right? It's parentheses 2, parentheses.
But I don't want to go. Wait, this is the homework?
Yeah.
Okay, hold on. Let me just close this stream.
Oh, you were streaming?